Hello, Ram. Thank you. So everybody, I'd like to introduce you to Ram Narayanamurthy. He is sort of like the head building scientist of the Electric Power Research Institute. Brilliant person. Back in the day, he invented the ice bear, at least a technical lead on that, where you could do thermal storage with ice. And ever since has been an intellectual leader on how we're going to electrify end uses and be sensitive to the grid, because he works with a lot of grid management organizations. So an intellect right at the right spot, you know, the in between usages and the grid. So today we're going to find out about electrification field results of low-income housing that he's been working on, and some really innovative technologies that they're bringing forward. Thank you, Ram. Take it away. And we can hear you, and your slides are not in presenter mode yet, just so you know.
Yes, I'm
Yeah,
trying to get myself on the video so you guys can see me too.
I gotcha.
Okay. So that's okay. It says you stopped it. That's okay.
Oh, you don't have to show your face. It's fine. You can just
Yeah. Okay. Thank you, Sean. And this is something I've been looking forward to for so many years. You and I have been talking about being part of this session. You're doing a great job. Sarah, that was a great presentation. Enjoyed every one of these presentations. So thank you so much. And it's kind of interesting. So just for those who might not be aware of EPRI, so EPRI is the Electric Power Research Institute. See, we work with electric utilities around the world, and we do research. We're a nonprofit, but we do public benefits research all the way from the generation side, all the way to customer and end use side. And so it's been a privilege. We've been EPRI, I think, has been working in electrification for about 40 years now. Many of the utility companies, like Southern Company, for example, have been spearheading heat pumps for many of those years. So it's an interesting journey. And as we go through the slide deck, please don't think I hate electrification or that I'm skeptical. I guess it's a part of going through what we have learned and trying to understand how do we overcome the challenges and the barriers, not just in California, but what we have learned from around the world with regards to electrification. So we did this is something that we are very proud of. It's a community in Southern California in Fontana where we did this was one of the first net zero communities in California. This was in 2014. I remember writing that proposal and realizing that I couldn't put the word electrification in there because fuel switching was not a good word at that point. So, but what we did do was, this was one of the first, I think, tests of looking at how do you electrify your heating, how do you electrify your water heating. So we put in some of the first generation heat pump water heater products. We had medium efficiency heat pumps. We also put in solar storage, tried to get to net zero, but also look at how to integrate net zero into the grid. And this was the second one was something more recent. Last year, we worked with Meritage Homes, who's one of the large national home builders, to do an all-electric net zero community in Southern California. It's a lot harder, I think, to do all-electric communities in Southern California versus Northern California. But so we've been very actively working with builders around the state, around the country, trying to get net zero as well as all electric communities in place. So with that preamble, let me go into what we've been finding and some of the outcomes and where we are looking at for new technologies in research. So one of the first things I want to mention is that California is not alone in decarbonizing. This is a map of all the carbon targets around the country. So you'll be surprised to find that there are carbon targets everywhere, right? There's not a single state that doesn't have a carbon target, whether that's because the utility has a target for getting to a clean grid, or whether cities have their own targets within that state, or whether the state has their own target. So you'll see different colors, but the fact is that there is a lot of impetus, and I think about 80% of the US population now is covered by carbon targets. So there's a lot of efforts going on. Part of what we try to do is bring in the efforts from everywhere, trying to coordinate, trying to learn lessons from what others are going through. So one thing I want to also kind of outline is that we look at it as two different sets of targets. One is clean energy generation targets. The other is economy-wide emissions reduction targets, and they drive different things. The economy-wide targets drive they drive building decarbonization. They drive electric transportation. They drive industrial decarbonization, as well as they also drive the grid decarbonization. So one of the key things is that as the grid gets cleaner, it makes it easier for cities and communities and states to get to the economy-wide emissions goals. But when you have a clean energy generation target, it mainly drives grid decarbonization. And how do they translate back into the building side? So the grid decarbonization is your driver for customer flexibility, demand response, storage, etc. And then the building decarbonization targets, which are driven by the economy-wide decarb targets, then drive efficiency, electrification, embedded carbon in buildings, as well as low carbon fuels. So, and there's some interesting work going on in low carbon fuels, like getting hydrogen instead of natural gas into buildings, especially in Europe right now. So where are we with electrification? So there is a lot of interest in electrification. There's a lot of efforts going on. City of Berkeley, I mean, you guys have been doing a great job trying to have that market transformation happen. But then there's also challenges that we are running into, right? I mean, as we try to decarbonize our existing building stock and do electrification, how do we get through that peak of inflated expectations, get into that slope of enlightenment where most of our customers and most of our homeowners and builders feel like, hey, electrification is the way to go, that getting to building electrification really helps them to get to their final targets. So I call this our big challenge, which is how do you decarbonize our building stock at $1 a square foot? We all know what happened with the $1 per watt challenge with solar and how it helped solar scale, all the technology work that went in, the policy work, permitting work. Now, how do we do the same for a building stock? How do we attain this target of decarbonizing our building at $1 a square foot? So if you think about it, if somebody has a 2,000 square foot home, how do we get the cost of decarbonizing that home down to about $2,000? So that's a pretty big challenge today, but hopefully there are ways to do it.
Quick question, Ram.
Yes.
Is there anything that might be whistling? A few of us can hear this. Like if I mute my computer, the whistle goes away. So I know it's something coming through Zoom. Do you think there's something in your background that could be making a very high-pitched whistle?
Wow. Okay. I don't.
I know you're like a technologist, so I'm not sure what you have around you. But don't worry, it's not bad.
Okay.
But
I'm
that's
sorry.
better.
Is it better?
That's
okay.
Perfect.
Okay. Perfect.
Yeah. Thank you.
So no problem. So we have this concept called affordability sequencing. The fact is, customers have a choice of what they can buy. They have a home, they can buy their EV, or you can buy solar, or you can buy heat pumps, you can buy heat pump water heaters, you might buy battery storage, or they might buy tankless or tank water heaters, right? So what we have to do is influence our customers to make the decisions that help us decarbonize. So if a customer were buying just based on carbon, what we see is that even today, electrification of the home saves the maximum amount of carbon after buying an EV. In fact, electrifying the home has more carbon savings than even putting in a 4 kW PV system. And in most cases, a battery by itself is not a carbon saving mechanism, mainly because of round trip losses and the fact that if you're charging at night, that's also high carbon times. But people don't do that, right? People choose based on cost, first cost, operational cost. And it turns out that when we do that, when we approach it from that angle, it turns out that building electrification is not as lucrative, right? Yes, this is the carrot side. The stick side would be trying to get building codes up there. It also tells us that, hey, there's a need for incentives. I know a lot of you are working on it. But also I wanted to highlight the fact that when you go to a place like Phoenix, in a funny way, the economic incentives are actually aligned with the carbon savings. There's reasons for that. In Phoenix, for example, like you look at it, the EVs, of course, they are the biggest carbon savings mechanism, and they have a pretty good economic incentive. And part of it is because their electric rates are lower. They have some very innovative time of use rates. They don't have as great a NEM incentive. So a lot of that essentially ends up aligning the cost savings for customers with their carbon savings. So here's another, I won't go into very much detail, but given where we are right now, I think Northern California is one of the hardest places to actually electrify our building stock. There are other areas of the country that are so much easier to do that. But then of course, if you have your time of use optimization and controls for time of use, then it starts making a little bit more sense where you can actually start maybe at least being cost neutral. So this is kind of a quick analysis just to kind of reiterate the importance of having controls and time of use management for our heat pumps and heat pump water heaters to make it more attractive to homeowners and customers to be able to electrify their building stock. So this is a quick discussion. I know there's been a lot of talk about how flexibility might help us with carbon. And one of the things that we see, of course, this is the California carbon intensity chart, whether it's today or in 2030. Our highest carbon hours are always going to be, are still going to be the midnight to 6 a.m. timeframe. But unfortunately, the way our TOU rates are set up is that that's when our all the flexibility devices end up charging. One of the other things we found was that when you do optimization, and this was not in California, this was in a different part of the country, a warm location, but a different part of the country, that the aggregate efficiency of heat pump water heaters went down quite significantly. And this was based on some algorithms that were implemented by national labs. But there is a impact to energy efficiency when you start implementing flexibility. So one of the things that I think the way we look at it is, okay, hey, flexibility, we should start looking at it and pricing it as a grid resource. And part of that would mean that, hey, we need to have open access, open APIs to battery storage, to heat pumps, to heat pump water heaters, so they can be managed as a grid resource, whether by the grid operators or by the third parties. But they are not by itself a carbon savings measure within buildings.
I'm
Yes.
trying to put that little whistling noise again, if you could. I apologize, but it's not terrible.
I'm so sorry.
That's better though, but it helps me, put you on full volume. And on this, just I'm clear. What we're seeing on the COPs, non-optimized, optimized, right?
Yeah.
We're seeing, like in March of 2019, it's 1.34 versus 1.32, but in February it was a significant drop. 1.37 down to 0.91 when we were operating the tank to work as a thermal battery, right?
Yes.
Okay.
Yeah.
Thank you for just going through that with me for a second. And you can see that
No problem.
it's more or less effect in some months.
Yeah. Some months it's greater, some months it's lesser. I think what we are seeing is that the average COPs are around 2.1, 2.2, even in warm climates for heat pump water heaters. And so that kind of impacts your customer cost benefit equation.
That's a really low COP. I mean,
well, those are rated at 3.75 UEF.
Right.
So I think what we are seeing from our field studies is that there is about a 1 to 1.5 point drop between UEF and COP in actual operation for heat pump water heaters.
Okay. That whistling is coming back a little bit, and I want to follow up that because that's sort of a tragic amount of efficiency loss, but continue. Thank you.
So let me keep going at time. So we know that rates are an issue. We'll get to that. We'll somehow figure it out. The other thing I wanted to say is that things like battery storage can be an enabler for electrification. It might take many customers might be concerned that if they electrify their homes, that they're going to be operating on high peak rates, which is the 4 to 9 time period. That's when, of course, your air conditioner runs. So we have to provide customers with a method and a mechanism so that we can help them shift their energy use off those peak hours, especially if you're going to ask them to electrify. So we'll have to figure out how to do all that. And then ultimately what that does is leads you back into that affordability issue. which is, hey, are we going to have customers where they're going to have to pay, I don't know, 10K for a heat pump, another $5,000 for a heat pump water heater, and now they have to add a battery, that's another $10,000. So it's an affordability issue that we'll have to address. So what that means is that we have to get to work. We have to reduce our first cost of installation, reduce our customer energy burden. Things like combining efficiency and electrification can be very effective. Weatherization is, I think, a big enabler for electrification. So we have to look at how do you combine those. We have to figure out how to enhance our customer benefits, indoor air quality, health benefits, right? Shape customer perceptions of new technologies. And finally, address core and grid readiness. And I'll get to that grid side piece. So just as an example, this is some work we are doing with affordable housing communities in Fresno and in Southern California. What we find is that the cost of electrification ranges from about $15,000 to $30,000 a home, and much of that is driven by the fact that you have to, if you add service to get 240 volts required for heat pumps and heat pump water heaters, that ends up adding distribution system upgrades. Then then you have to do the panel upgrades, the 240 volt to wiring to location. So all these costs start adding up, right? So we have to figure out how can we approach technology, find technology solutions, application solutions that can help us avoid those costs. Now, this is another project that we did in Ontario. The good news is that even after electrification, because of efficiency, the tenants' energy bills went down overall. Right. So what we find is that in a lot of affordable housing, the tenants pay the electric bill, but the owner usually pays the gas bill. So when you're electrifying, you're shifting the energy burden from the owner to the tenant. So it's really important that we figure out pathways by which electrification can reduce tenant energy bills, and efficiency becomes a core part of being able to help the tenants out. Just quick, I'll skip through this. The gas usage, of course, we were able to see like 70% reduction in gas usage from electrification. But when we talk to the residents, I think one of the big benefits that they see is that through weatherization and window replacement, their indoor pollution levels go down substantially. So whether that's PM 2.5 from smoke, or whether it's from traffic pollution, whatever it is, weatherization measures make a big impact on the quality of life for the occupants. Here's another example when we went through how trying to electrify a whole apartment complex, and this one had swamp coolers. So we try to replace them with compressor-based cooling, and essentially the cost numbers we ended up with for some of these apartments were significantly higher. So we went looking around the world, and thanks Sean. I mean, Sean led us to one of the viable products. So we were able to bring in the 120 volt heat pump technology from Italy, brought it in, installed about 140 of these. Very easy to install. You don't need to break down walls, avoids things like asbestos mitigation because you are not breaking down walls. And we put out about 140 of these, got them field certified. They're all up and running. So now all these tenants have a much better air conditioning system, but not using that much more energy. So the original swamp coolers, they were running straight out every day, day in, day out, right? And then with these systems, we are able to significantly reduce the energy use went up a little bit, but not very much. And so it's proving to really improve the quality of life for these customers. And then just
can you clarify that? It's because there is a modest increase in energy consumption, but is it coming with greater services? Is that what you're saying? Like, are people familiar with this?
Yes. So what people like is the fact that before, with the evaporative coolers, when it's 110 outside, you couldn't get those homes below like 85, 90, right? And it felt like a sauna. It felt like you were in Houston every day, right? And there are mold issues. There was a lot of indoor air quality issues. And with these PTACs, you're doing two things. You're getting rid of wall heaters that have incomplete combustion issues. And so you're potentially reducing. We are still looking at the indoor air quality data. We are collecting it, but we haven't fully analyzed it. you could potentially be reducing the NOx and the carbon monoxide inside homes, as
Uh-huh.
well as getting rid of things like mold issues, right? That come from having evaporative coolers. So
What can they get the apartments down to now when it's 110 outside? How comfortable are they?
they are getting it down to 60 degrees.
Woo!
Okay, that has a different problem, but people are so happy because now they have the control. They have an app, so they're like, okay, I've never had proper cooling before, so they're just
Yeah.
driving it straight down to 60, which creates a different set of problems because now your coils freeze up and everything. So we are working on how do you set it up in like a hotel mode where you can have centralized management. Okay, if you go to hotels, right, there's the intercom systems that can limit how low you can take your temperatures down. So we are working on tuning that out, but these systems are really capable of providing really good cooling to these homes.
Yeah,
And also
my
energy.
elderly mother is sensitive to getting overheated. She'll get like heat stroke easily, and it's been a big deal for me this summer. Even the cool environment where I'm at, to rush her inside a couple of times this summer and get her into cool weather. So I can
Yeah,
understand people might need it to be 60 degrees sometimes to recover from it being 110 outside. Dear God. Okay,
yeah,
continue. Thank you.
no problem. And one of the things I wanted to mention, right, is that for a lot of coastal California where it's getting hotter and you don't have enough electrical service, that's one of the areas I think products like this could be useful, because these are 120-volt products that can go into existing buildings without requiring panel upgrades. So um, it's an applications issue, but that's really what led us to search for products that could work. Um, Water heater electrification. I'll tell you, this is my dream water heating product: a zero GHG refrigerant, no electric resistance. You run it from 6 a.m. to 3 p.m. Hopefully, you can overclock it, run it at, store it at 160, and not have to have external controls and demand response measures and all that stuff. Um, if you get a water heating product that can run consistently at low power during the lowest carbon times of the day, we shouldn't even need demand response from water heaters. So this is our experience on how we try to do water heating retrofits. So many of these apartment communities have 40-gallon storage water heaters. There is no direct one-on-one replacement for 40-gallon with heat pump water heaters. So we ended up going to carbon dioxide water heating, put in like a single storage tank that can service multiple units, as well as add additional storage. So we are working with we are going to be working with Ecotope on a new project with the California Energy Commission to test the Mitsubishi QAHV systems also, as part of this as part of retrofit solutions for water heating for multifamily. I'll go through quickly. There's New Hope. We are looking at what we call 1500-watt products for water heating that can go in as 110-volt systems. Some of these are in China, so we're bringing them in. We are testing them out. The whole goal is that you don't have to upgrade your electrical in your building. So there's some test facilities in Southern California where we are testing some of these, comparing them to existing water heating products. Hopefully some of these work out, where even if they're 220 today, if they're running at 1500 watts, hopefully they can be converted into 120-volt products that can be easily retrofitted into existing buildings. So the whole concept here is, we know there are challenges with existing electrification of existing buildings. They're really driving up the cost of electrification. So what we're looking at is technology solutions that can really drive down the application cost. It's not about just getting the highest efficiency product out there, but trying to find products that can go in to electrify our existing building stuff. New construction, I'll skip through it. We're again doing some work on VRF, centralized heat pump water heaters. And there's some business model issues around how utility rates can be passed on to tenants with centralized systems. Skip through it. Sean, you and Yanda and Sean are going to be working to solve this whole storage issue with central heat pump water heaters. Excited about it. We
Yeah.
look forward to hearing more from you guys as you work on that. That's a very important thing, because the more you can figure out how to get your storage optimized, I think it's really going to help us with reducing the load on buildings, and help with existing building retrofits. And these are some other decarbonization products we are playing with. So we brought in some products from Denmark for propane heat pumps. Again, trying to get greenhouse gas emissions out of the refrigerant side. We are working with CO2 heat pumps from Japan that might be usable in multifamily and small commercial. Another one that I'm excited about is a product. It's essentially an air handling product, but the way it's designed to slow down the air going through the air handler so that you can get better humidity control, which means that if you get better humidity control, you don't have to reheat the air. The way a lot of commercial buildings work today is your chiller cools your air down to like 50 degrees just to take the humidity out. And then you have all this gas being used for reheat loops, right? So if we can get better humidity control so that you don't have to use gas for reheat, or even take the reheat load low enough so that you can use heat from water heaters for reheat, then you can start electrifying your big commercial buildings. And then finally, another product that we are looking at and doing some research on is high lift heat pumps that can be used for large commercial buildings. So just a whole range of different technologies that we are working with. With that, I think that's the last one. That was a random walk in the woods, starting from how consumers might make their choices to new products and technologies that might help us transform the building stock. So with that.
Woo! Ah, fantastic, man. It was delightful to see some of the products that you're testing. I've been dying to get like just to see them. What are you doing back there? That's awesome. Congratulations on I think you're bringing forth some radical change in product availability, which of course is a linchpin to a lot of our work, is just having the appropriate products through inexpensive electrification. A question for you. You wanted to sort of do a $1 square foot challenge. And what is your thinking on how that could be accomplished for electrification?
Great question, Sean. I think first, what we are hearing from builders, the supply chain for heat pumps is not working. Okay. So even builders who are doing new all electric communities today are going back to gas because their supply chains are charging $3,000 more for heat pumps that should actually cost less. I can go buy a heat pump in Alabama that's $1,000 less than a gas furnace system, but that same product costs $3,000 more in California, right? So we'll have to fix the supply chain for these products. The second is if we can get our grid ready, right? Let's invest in the grid, put in more transformers, more wiring so that we are electrification ready, so that the cost doesn't fall on the customer. That's a big one. And then third is getting all these products tested and applications vetted out and our workforce ready so that we can start launching these and scaling these as many of our cities start moving these programs forward.
All right, that was wisdom. Thank you. Are there any other questions here on the side? There's some bunch of discussion on grid balancing, and could you speak a little bit to the window air conditioners that have potentially Mitsubishi?
Oh yes. So we are working with a small company, Tro, on developing propane window air conditioners. So it's being actually through I think the State Climate Grants Commission. So it's still very early stage, so I couldn't really talk about the technology itself, but the goal is to have low window air conditioners at the cost of window air conditioners, but at efficiency of split system heat pumps. So much higher efficiency window air conditioners that can help us electrify our buildings.
And they're heat pump, window heat pump.
Yeah, window heat pumps. Sorry, yeah, not window air conditioners. They are window heat pumps. So they're propane window heat pumps.
And propane, because that has a global warming potential of 3,
yes,
as opposed to say 1800, like
yes,
the
and
right
exactly.
Now.
And so when you go to window heat pumps, the amount of propane you need is so small that you can actually get under the EPA SNAP limitations.
Excellent. So if there's a little enough propane, you're saying that it's safe and we can get in, you can use it without getting into legal complications, like
yes.
Is that what you're trying to say? Because just earlier today, Yehuda was presenting on the Innova, and he was saying that propane wasn't really welcome in the United States. But what you're saying is that you've got a strategy to use so little that it's okay.
Yeah, because if you look at it, you even today, right? You have a lot of propane
Refrigerators?
refrigerators, yeah, refrigerators, but
Oh,
also the where you have the soda machine, the soda,
oh, right, okay. Soda dispensing,
in
yeah,
the convenience stores, right? A lot of them are moving to propane. The chilling cases are moving to propane.
oh,
So yeah.
okay, so we should get to ask this for our products too. Okay, well, there's so much more. Ram, I really appreciate your time. Thank you. I know you had to do some meeting shifting around, and as you mentioned earlier, this is the first time I've gotten you here after years of begging you to please present. Thank you. You dumped a whole bunch of great stuff into my mind already, and I'm sure for everyone else too. But just selfishly, that was great.